Welcome back, students. In all these days we have been doing different topics in solid state, right? We've done the packing efficiency, we've calculated the number of atoms. We're almost end of the chapter. After these two topics we'll be doing a list of 10 to 15 numericals in solid state chapter. So today the topic which I'm going to discuss is called defects in solids. So let us write the topic: defects in solids. Right. Why do we get these defects? We already said solids are rigid in structure, right? It's very difficult to compress the solids. But let us see the factors for which I'm going to introduce the defects or imperfections in the solids. Basically, when I speak about a solid, right, we very well know at 0 Kelvin, right? If I to the temperature of 0 Kelvin, so you perfectly find a typical crystal, right? A perfect crystal, a typical crystal, but it's very difficult. So at 0 Kelvin I find a typical crystal. But now when I start increasing the temperature, so what am I doing now? I'm going to take the solid, I'm going to increase the temperature. When I increase the temperature, gradually there is certain amount of what happens to the solid. Suppose this is a solid. I'm going to introduce, I started heating this solid. When I start heating this solid, what happens to this? Slowly you'll find thermal motion, right? You are introducing thermal means heat. So because of this increase in temperature into the solids, there's thermal motion, and because of this thermal motion there's certain amount of disorderness created in the solids, right? You have studied in your thermodynamics last year. So the certain amount of disorderness, that disorderness, or the other way called as, there is increase in entropy of the system. When the entropy is increased in the system, so now what happened? 0 Kelvin, perfect crystal. Now gradually what did I do? I increase the temperature. When I increase the temperature, there's certain amount of disturbance which is created in the solid. So because of this thermal motion, when I go into the solid, observe the solid, there's certain amount of entropy which is created in the solid. Means some disorderness, a disturbance which is created. Because of this disorderness, three important factors which really affect the solid. What are those? First, the solid, you are mechanical stress, right? You're creating a sort of mechanical stress onto the solid, right? Because you have already increased the temperature, there's already a disorderness created in the solid, and because of this mechanical stress, what else, ma'am? What else is affected? When I increase this disorderness or entropy, this also affects. So I'll write this as Fx. This also affects the electrical conductivity. Electrical conductivity also affects. Now, because of these imperfections or defects. Now, when we already studied Bragg's equation, remember? The same way, because of this entropy or because of this disorderness or increase in temperature, in this particular solid, even optical activity also is changed. Your optical activity also affects. Fine. So I just give you an introduction. I just wanted to show you what is the use or what happens when certain imperfections or defects are created in the solid. Fine. Now your board wants you to learn the different types of defects in solid. Now I told you the condition. Now all these defects or whatever entropy and all these, I can observe using electron microscope. I can use the electron microscope to observe all these defects. Fine. Now this is not the criteria for us. Let us come back to the main topic. So now I said defects are already introduced, right? Now already entropy has entered or disorderness has already seen in the solids. Now let us see the type of defects. So when I say defects or in solids, the other name given for defects is imperfections. Imperfections, right? Imperfections, the other name, if I can say, vacancies. Okay, vacancy. Why am I giving all these terms? I'm giving these terms because in your exam, when a question is asked, how is the density increasing or decreasing due to this imperfection, don't get confused. Imperfection is basically a defect, a type of defect. Basically, your defects are divided into two types, right? Those are point defects and line defects. Right. When I speak about point defects, these are further divided into impurity defects, stoichiometric defect, non-stoichiometric defect, non-stoichiometric defect. Yes, yeah. Stoichiometric defects, the other name given for stoichiometric defects are intrinsic defects. Remember, intrinsic. What are intrinsic? Basically, when a certain amount of defects are arising due to change in temperature, right? The other name, or you are increasing or decreasing the temperature, then these are called intrinsic. Intrinsic or thermodynamic effects. If I speak about impurity defects, they are also called as extrinsic defects. These are not dependent on any increase or decrease in temperature. Concept of temperature doesn't exist. So impurity is also called extrinsic defect. Extrinsic defects. Right. Extrinsic defect means basically you are introducing an impurity into the solid, right? You're doping some impurity into the solid, because of which you're finding those impurity defects. So intrinsic defect or impurity defect. Fine. So your Schottky defect, and let us further see the classification. Your Schottky defects or your psychometric defects are further classified into 4. 1, 2, 3 and 4. Let us see. Stoichiometric defects are again classified into Schottky defect, double TKY, Schottky defect, Frankel defect, vacancy defect, and let me take this and write it here, interstitial defect. Right. Basically, your Schottky and Frankel defect are they are shown by ionic compounds like sodium chloride, cesium chloride, zinc chloride, right? So Schottky and Frankel are seen in ionic compounds, ionic. And when I speak about vacancy and interstitial, they are observed by non-ionic compound, right? When I come back to non-stoichiometric defect, let us see 2 more classifications. Non-stoichiometric defect are again shown, or they are further classified into metal excess defects and metal deficiency defects, right? This is the classification. Fine. So I'll be teaching, or I'll be dealing with one topic individually, and let us see if there's any numerical also related to this. Please note the topic.